Take a look at this question from an SAT practice test. It asks us to find the equivalent of 3 minus 5i over 8 plus 2i. Having an imaginary number in the denominator can make the expression look unsolvable at first glance. Our goal is standard form, a plus bi, I squared equals -1. Even though the initial setup looks complex, clearing the imaginary unit from the bottom of the fraction relies on a specific, repeatable process. We begin by looking at the denominator. That 8 plus 2i is what's preventing the fraction from being in standard form. To address this, we use a tool called the complex conjugate. To create the conjugate, you keep this turns 8 plus 2i into 8 minus 2i. It is important to only change that middle sign. The leading 8 remains positive. Now we multiply both the top and the bottom of our original fraction by this conjugate. Since any number divided by itself is 1, we are changing the format of the expression without altering its mathematical value. Setting up this specific multiplication is the essential first step for any problem involving complex fractions. We'll solve the bottom half of the equation first, multiplying the original denominator by its conjugate. There's a shortcut here. When multiplying conjugates, the middle terms always cancel each other out. This leaves just the squares of the two coefficients, 8 squared plus 2 squared. This calculates to 64 plus 4, giving us a final denominator of 68. Because we have arrived at a clean whole number, we know the conjugate strategy has successfully neutralized the imaginary part on the bottom. Now we move to the top half, where we need to multiply the two numerators, 3 minus 5i and 8 minus 2i. We'll use standard FOIL steps. First, 3 times 8 is 24. Outer gives -6i. Inner gives -40i. Finally, the last terms multiply to +10i squared. We combine the middle imaginary terms to get -46i. This leaves us with 24 minus 46i plus 10i squared. Notice the I squared term at the end. It is the final component that doesn't yet match our real and imaginary target format. Substitute that I squared with a -1. This changes the operation, turning +10 into -10. To finalize the numerator, combine the remaining real numbers. 24 minus 10 is 14, giving us 14 minus 46i. By sticking to standard binomial multiplication and addressing the I squared term, we've turned the top of the fraction into a simple two-part expression. Now, reassemble the fraction using our new numerator and denominator, 14 minus 46i, all over 68. While this is mathematically correct, test answer choices are almost always presented in a separated format. We can split this into two distinct fractions, 14 over 68 and -46i over 68. Finally, reduce both fractions by dividing the coefficients by 2. This leaves us with 7/34 minus 23/34 I. Splitting and reducing the fraction ensures our result aligns with the strict formatting standards used on the exam. Let's bring the original question back to see how our result compares to the options provided. Our calculated answer matches option C exactly. Remember the three-step rule for any problem like this. Find the conjugate, multiply the top and bottom, and substitute -1 for any I squared terms. You may want to take a screenshot of these steps. I've also included a practice worksheet down in the video description to help you build your mathematical muscle memory. Mastering this specific, repeatable process transforms what looks like an intimidating problem into guaranteed points.